Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on today's video, I'd like to ask you to please subscribe to the channel, give this video a thumbs up, and engage with a comment below. This video is looking at Geometry, Unit 3, Lesson 15, titled Converse of the Pythagorean Theorem. We do have two learning goals for this lesson. Number one, I can decide whether a triangle is acute, meaning the angles are less than 90 degrees, right, meaning one of the angles is 90 degrees, or obtuse, meaning you have an angle larger than 90 degrees, based on the side lengths. And learning goal number two, I can find possible side lengths for a triangle when I know the lengths of two sides. So you're going to be able to determine what is the smallest length that third one could be and what is the biggest length that third one could be. Because remember, two of the sides need to be as long as the longest side plus a little bit more so that it can pop out from being a line into a triangle. So for our lesson summary, the Pythagorean theorem describes a relationship among the side lengths of a right triangle. In particular, if the sides are labeled A, B, and C, with C as the longest side, also known as the hypotenuse, then A squared plus B squared equals C squared. The converse, or opposite, of this theorem is also true. In fact, we know the lengths of all three sides. We can classify the triangle as either acute, right, or obtuse. If we put the numbers into the Pythagorean theorem and C squared equals A squared plus B squared, then the triangle has a right angle, and it is a right triangle. If, however, C squared ends up being greater than A squared plus B squared, then the triangle has an obtuse angle, meaning one of the angles is bigger than 90 degrees. And if C squared ends up being smaller than A squared plus B squared, then the triangle has only acute angles, meaning all three angles are less than 90 degrees. So this is a pretty quick and simple way to test it out and figure out what type of triangle you are dealing with. A key reason this is true is due to the relationship between an angle and the side opposite the angle in a triangle. If the two segments making up the angle are constant, then when the angle is made greater, the opposite side must also be greater. So think about a triangle, and you have the point of the triangle towards yourself. And so you've got that opposite side away from you. And this is saying that as we widen that angle that is pointing towards us, then that opposite side needs to be getting longer. So the bigger the angle is that's pointing towards us, then the longer that opposite side needs to get in order for our sides to still reach out to it. Another relationship among the sides of a triangle is due to limitations from the ways the ends of the segments can be connected. The length of any side of a triangle must be less than the sum of the other two side lengths in the triangle and must be greater than the positive difference between the other two side lengths. For a triangle with side lengths A, B, and C, this can be rewritten as A plus B, the two shorter sides of the triangle. If I add those together, they must be greater than C. And if you think about that, if I've got this long line, C, and then I've got these two shorter lines, A plus B, if I add those A plus B end to end, and they are shorter than C, then I wouldn't even reach from the beginning of C to the end of C. I'd have a line that's shorter than the other line. So there's no way I could form a triangle with that. And if I take those two shorter sides and I add them together end to end, and they equaled C, well, now I just have one line directly on top of another line, and I don't have a triangle yet. I need those two shorter sides to be longer than C. That way, when I put the ends together, then my A and B can pop out a little bit where they're joined, and now I can start having a triangle. So the two shorter sides, A and B, must be longer than C. Otherwise, it's not going to form a triangle. Now, the other way that this can be rewritten is that the absolute value of A minus B needs to be shorter than C. So if I take one of those short sides and I subtract it from the other short side, then whatever's left over needs to be less than that long side C. If the third side is too long, then putting the other two sides end to end will not be enough to reach both ends of that third side. If the third side is too short, then putting it at the end of one of the other sides will not be enough to reach the end of the other side. So we can't have C be too long, and we can't have C be too short. Otherwise, my three lines are not going to come together, or they're not going to come together and form a triangle. So now let's go ahead and take a look at practice problem number 1. This says a triangle has sides of length 8, 10, and x. What value of x makes it the hypotenuse of a right triangle? So if I know that I have 8, 10, and x, but specifically we want x to be the hypotenuse, then that means 8 can be A, 10 can be B, and x is going to be C. So now we have our Pythagorean theorem, a squared plus b squared equals c squared. This is going to become 8 squared plus 10 squared equals c squared. 8 times 8 is 64. 10 times 10 is 100. And 64 plus 100 is 164. Now, this gives me c squared, but what I really want is c. So I'm going to take the square root of both sides, and this gives me the square root of 164 equals c. Now, I could leave it like this, or I could try to go ahead and simplify it. And so if I'm going to simplify it, I've got to think, what are some perfect squares that go into 164? And the first one I can think of is the square root of 4. I can say that this is the square root of 4 times the square root of 41. Because 4 times 41 is 164. Now the square root of 4 is 2. So my simplified answer is that 2 times the square root of 41 is going to be the length of x that makes it the hypotenuse. If you have any questions, please feel free to leave a comment below. Practice problem number 2. Complete each inequality so that it describes possible lengths to make a triangle. So remember, on my extremes, it can't be too small, but it also can't be too big. So the first thing I can do, remember we said 2 different formulas. We said A plus B must be greater than C, and we said that the absolute value of A minus B must be less than C. So let's try the first one. We're going to say 6 plus 8 equals 14. So we know that together they've got to be greater than 14. So x must be less than 14. But now if we say the absolute value of 6 minus 8 must be less than c, then 6 minus 8 is negative 2, and the absolute value of negative 2 is 2. So on my low end, this missing value here needs to be bigger than 2, and then it could be the shortest length, but it would still allow this to be a triangle. And then on the long side, it needs to be less than 14, otherwise 6 and 8 can't go together and reach the end of it and make it a triangle. So now let's look at number 2. I've got 13 and 17. So if I add them together, I get 30. So this other side must be less than 30. Otherwise, these 2 lines will not be able to reach the ends and form a triangle. On the other side, if I do 13 minus 17 and I take the absolute value, then 13 minus 17 is -4, and the absolute value of that is 4. So on the low end, this missing side y must be greater than 4, otherwise 4 and 13 are only long enough to reach the ends of 17, but not long enough to pop out and form a triangle. Now let's try number 3. The first way is adding them together. 5 plus 5 is 10, so this missing side z must be less than 10. If it's not, 5 and 5 cannot reach the ends of 10 and have leftover to pop out and form a triangle. On the other end, 5 minus 5, the absolute value, that's the absolute value of 0, which is 0. So obviously a side length has to be greater than 0, otherwise it doesn't exist. And if I add 0 to 5, I get 5, so I really just have one line on top of the other with nothing left over to pop out and form the triangle. And then our last example, number 4. First we can say that A is the long one, so we add these together. We say that 98 plus 100 equals 198, so our side length must be less than 198. Otherwise, when I add 98 and 100, it's not long enough to reach both ends of 198 and have leftover to pop out and form the triangle. On the opposite end, let's say 100 is the long end. So 98 minus 100, that is -2, and the absolute value of -2 is +2. So A must be longer than 2, otherwise adding 2 and 98 is not long enough to reach both ends of 100 and have leftover length to pop out and cause the triangle. So I hope you can see what we're getting at here. We need these sides, the two shorter sides, to be long enough so that they can reach both ends of the long side and have leftover length to then pop out and form the triangle. If you do still have any more questions about this, please feel free to leave a comment below. Practice problem number 3. A triangle has sides of length 5, 7, and x. Number 1, complete the inequality so that it describes possible lengths for x in an acute triangle. Complete the inequality so that it describes possible lengths for x in an obtuse triangle for number 2. So if you remember, we said that it is acute when c squared is less than a squared plus b squared. We said that it is right when c squared equals a squared plus b squared. And we said that it is obtuse when c squared is greater than a squared plus b squared. And we learned a couple of ways to find lengths. We said the longest length comes when we take A plus B, and that is longer than C. So if we want X to be the longest, then we have 5 plus 7 equals 12. So for the obtuse triangle, the long end is 12. Our side length must be less than 12. Otherwise, 5 and 7 are not going to be long enough to reach both ends of it and have anything left over to pop out as a triangle. So that'll find the longest that it can be. All right, just less than 12. The opposite end is finding what is the shortest it could be. And we said that happens when you take the absolute value of A minus B, and that is less than C. So let's take the absolute value of 5 minus 7, which is the absolute value of negative 2, and absolute values turn negatives positive, so that is 2. So for the acute triangle, the absolute shortest is that it must be longer than 2. Otherwise, 2 plus 5 is not going to be long enough to reach both ends of 7 and have left over to pop out into a triangle. So now what we need to find is where is that length that's going to make it a right triangle. So we're going to set up the Pythagorean theorem, and we're going to say for the midpoint, this is when we're going to have a squared plus b squared equals c squared. So we have 5 squared plus 7 squared, that equals 25 plus 49, which equals 74. But I need c, not c squared, so that means c, or in this case, x, is going to equal the square root of 74. And that is my midpoint. So anything between 2 and the square root of 74, and I'm going to have an acute triangle. When x is the square root of 74, that's my midway point, because that's where I'm going to have a right triangle. And then anything bigger than the square root of 74, but smaller than 12, and I'm going to have an obtuse triangle. And then if that missing length is 2 or less, then it's not going to be long enough to reach 7 and still have anything left over to pop out and make a triangle. So we don't have a triangle if it's 2 or less. And anything 12 or longer, and 5 and 7 will not be able to add together, reach both ends of it, and have anything left to pop out into a triangle. So anything 2 or less won't be a triangle. Anything 12 or more won't be a triangle. Square root of 74 is where it's going to be a right triangle. So anything between 2 and the square root of 74, not including them, will give us an acute triangle where all the angles are less than 90 degrees. Anything between the square root of 74 and 12, not counting those endpoints, will give us a triangle that is an obtuse triangle, So one of my angles is greater than 90 degrees. I know this is a lot of different formulas and substituting numbers in, but I do hope that this makes sense to you. If you do still have any questions, please feel free to leave a comment below. Practice problem number 4. For each set of side lengths, state whether it is an acute triangle, right triangle, obtuse triangle, or impossible to make triangle. So let's check that last part first. Remember, if we are going to make a triangle, then the two short sides must add together to be greater than the third side. And if you look at numbers 1 through 4, they have the exact same short sides, 20 and 21. So if we add these together, 20 plus 21 equals 41. So 41 must be greater than the third side. Well, number 1 is fine. 41 is greater than 29, so we're good there. Number 2 is fine. 41 is greater than 30. And number 3, we're fine. 41 is greater than 27. But when you get here to number 4, 41 is not greater than 55. So if I put 20 and 21 end to end, they are not long enough to reach both ends of 55. Therefore, we do not have a triangle. So number 4 is impossible. Now let's check number 5. 20 and 20 are the short sides. And that equals 40. So 40 must be longer than the third side. Well, the third side is 21, so 40 is plenty. So number 5 is good. And then the last one, number 6, my short sides are 1 and 20. Well, they add together to equal 21. So 21 must be greater than my third side. However, 21 is my third side. So if I put 1 and 20 end to end, they are just long enough to reach the ends of 21, but there's nothing extra. So this is one line laying on top of another. There's no extra length to pop out and create the triangle. So that means number 6 is also impossible. So now we know which 2 sets of side lengths are impossible. Now we need to look at the other 4 and determine if they are acute, right, or obtuse. And here's the rules that we're going to use. It will be acute if c squared is less than a squared plus b squared. It will be a right triangle if c squared equals a squared plus b squared. And it will be obtuse if c squared is greater than a squared plus b squared. So let's look at number 1. My long side is 29, so that is c squared. My short sides are 20 squared and 21 squared. I just need to know what the relationship is. Well, 29 squared is 841. 20 squared is 400. And 21 squared is 441. 400 plus 441 is 841. My two sides equal each other. That means number 1 will form a right triangle. Now let's look at number 2. My long side is 30. My short sides are 20 and 21. Well, 30 squared is 900. My other two sides I just figured out. Remember, we said 1, 2, 3, and 4 had the same short sides. So the right side of this is going to be 841 again. Well, 900 is greater than 841. Since c squared is greater than a squared plus b squared, that means number 2 is an obtuse triangle. Now let's look at number 3. This time, my long side is 27. My short sides are still 20 and 21. 27 squared is 729. We know that since 3 has the same short lengths as 1 and 2, the right side here is going to be 841 again. We have 729 on the left. That is less than the 841 on the right. In this case, since c squared is less than a squared plus b squared, that means number 3 is an acute triangle. And then number 5, my long side is 21. My short sides are 20 and 20. 21 squared is 441. 20 squared is 400. 400 plus 400 is 800. 441 is clearly less than 800. So again, since c squared is less than a squared plus b squared, this will be an acute triangle. I hope this explanation and demonstration makes sense to you, but if you do still have any questions, please feel free to leave a comment below. Now let's go back and review our learning targets. So our learning goals, remember we did have 2 of them. Number 1 says I can decide whether a triangle is acute, right, or obtuse based on the side lengths. Well, remember, C is my long side. A and B are the 2 shorter sides. If c squared is less than a squared plus b squared, then it is acute. If c squared is equal to a squared plus b squared, then it is a right triangle. And if c squared is greater than a squared plus b squared, then it is an obtuse triangle. Learning goal number 2, I can find possible side lengths for a triangle when I know the lengths of two sides. This is where first we said add the two sides together that I know, and those two must be greater than my missing side. So that gave me the high end of my range. Then we said I'm going to take a minus b, but I'm going to take the absolute value. And that was going to give me the low end of my range. So my third side needed to be somewhere between that low end and that high end. But remember, we did not include those two end numbers, because if it's the low number, then the other two aren't going to meet up. And if it's the high end, then they won't be able to reach and pop out. So I hope that this explanation, I hope these practice problems make sense to you. If you do still have any questions, please feel free to leave a comment below. I would like to say thank you for watching this video. If you find my explanations helpful, please subscribe to the channel. You'll get notifications when I release new videos, and it helps the channel grow and reach more people. Also, please give this video a thumbs up. It helps me out with the algorithm, gets these videos in front of more people. Leave a comment below if you have any questions, or if you just have comments. Please leave those below. Your engagement really helps me grow the channel. And if you find my style of explaining math to be helpful, I do offer one-on-one tutoring sessions. So if you check the pinned comment, you'll see tutoring links for where you can go online and schedule these one-on-one tutoring sessions. I really appreciate your time in watching this video, and I look forward to seeing you in the next lesson.